Hello students, we are going to start now a new topic of the Unit 4, that is wind energy. So let us start with a brief introduction of wind energy. As you all know, wind energy is considered as one of the clean sources of energy. There is nothing much, but of course a specific weather system is needed for setting up the wind farms. The condition of the wind and basically its speed is one of the significant factors for producing the energy through the wind. If one thing has some advantages, there are some limitations too. So in extracting the energy through the wind, there are few limitations. Like if we have a large wind farm and there are so many wheels are available there, in that case it creates a lot of noise which affect the surrounding population, migratory birds, or maybe the radar signals can also be affected in some manner. Although there are few limitations in that case, but still there are so many advantages. And the major one is that it is environmental friendly. And that is the reason only we are scaling up the use of wind energy, as this is one of the renewable source of energy. Historically, windmills are used for the mechanical purposes like grinding grains, pumping water. But nowadays, this is one of the major source of producing the electricity. Windmills, or we can say wind turbines, are majorly used for the production of electricity in all over the world. Now the major question arises, how does a wind turbine actually work? So the wind turbine operates on a very simple principle. The energy in the wind turns 2 or 3 propeller, which are also called as blades, around the rotor. The rotor is connected to the main shaft. As you can see in the figure also, in the middle there is a rotor which surrounds by the blades and is connected to the main shaft. It spins a generator so that the mechanical energy is converted into the electricity. So in the summarized way, we can say the kinetic energy of the wind is first converted to mechanical energy, and then ultimately it is converted into electricity or electrical energy through the generator. Now the important thing is, what are the requirements for setting up a windmill? The first one is wind speed. At least 16 km/h speed of wind is required for the efficient production of energy. The second point is minimum fluctuations in wind speed. It is required that the disturbance in the wind speed or in the wind should be low. The third point is access to transmission capacity. Means the selection of site should be in such a manner that the electricity can be transmitted easily to the surrounding. I also want to add a note in this that the site selection for setting up a windmill is very, very important. It requires a very long period. It requires a lot of homework for the economic and efficient production of wind energy. In this slide, we'll discuss about the scenario of wind energy all over the world and in our country. So, as according to the data of 2015, it is appreciable to note that India is at 4th position, having 6% of share in total world production of wind energy. And in the another pie chart, you can see very clearly that Tamil Nadu is the leading state of India in producing wind energy of approx 27%. There is a village in Tamil Nadu, Mupandal Wind Farm near Kanyakumari, which is producing 1500 megawatt of electricity and is largest in India. Now we will discuss about the types of windmills. So basically there are two types of wind turbine. The first one is horizontal axis wind turbine and the second one is vertical axis wind turbine. So starting with the horizontal axis wind turbine. As the name suggests, it contains shaft in the horizontal axis, means parallel to the ground. You can see in the figure also, it's a very tall structure, a very tall tower, and due to which these types of windmill are able to acquire the stronger winds. Blades are able to capture the wind energy throughout the rotation. Means all the blades are facing the wind in the same manner. There are few limitations in these types of windmills. The first one is its complex structure. As you can see in the figure also, in the shaft there is a generator attached with it. So to hold the generator at a very high position, it is required that the structure should be very rigid, should be very strong. So because of this, the complexity is associated in these types of windmill. Secondly, if the direction of the wind is not facing the blade properly, then it is required to turn the whole setup through the shaft in according to the wind direction. And it is really very difficult to adjust the whole setup according to the wind direction. Now the second wind turbine is vertical axis wind turbine. So these types of turbines have a vertical axis which is perpendicular to the ground. They generate power independent of wind direction. As you can see in the figure, the blades are arranged in a different manner, which is not necessarily facing the particular direction of wind. The structure is also very different as compared to the horizontal axis wind turbine. They are not that much taller. They are not that much rigid. The generator and the gearbox is placed near the ground, and hence, due to simplicity in their structure, less rigidity in the structure, these types of turbines have low cost or more economical as compared to horizontal axis wind turbines. But on the other hand, they have some limitations too. They have low efficiency because only one blade works at a time, or we can say facing the particular direction of a wind. Due to its less rigidity, as we have discussed, they require some support, they require some wires to support their structure. As the structure is not that much taller, the wind near the ground is more turbulent, is more disturbing, which affects the efficiency of these types of turbines. So as we have discussed the advantages and disadvantages of both these types of turbines, now coming to the applications. Horizontal axis wind turbines are more efficient as compared to vertical axis wind turbines. As in the horizontal wind turbines, all the blades are facing the particular direction of a wind or the same direction of wind. Hence, we are using the horizontal axis wind turbine at a large scale. For the large scale of production or producing the electricity at large scale, we are using horizontal axis wind turbines. And for the production of electricity or energy at a small scale, we are using vertical axis wind turbines. Now moving to the next slide, which is the estimation of power generation through the wind energy. So generally the large wind turbines have the capacity to produce 2 to 3 megawatt of energy. In practical, the fraction amount of energy we can get through these wind turbines, as you can see, 25% the capacity factor is mentioned in this slide, which means we'll be getting 1/4 of the capacity that the turbine is rated for. So we can get the exact amount of energy which we'll get through these wind turbines. See the mathematical formulation in the slide. 2 megawatt is the energy, multiply by the capacity factor, which is 0.25 or 25%, multiply by 3600 seconds, multiply 24 hours, multiply 365 days. So in total energy we'll get is 1.6 into 10 to the power 13 joule. As we already know that the total human consumption per annum is 500 exajoule. So if we are calculating that how many wind turbines are required to fulfill this particular amount of energy. So by dividing both the numbers, we can get the number of wind turbines. In case if we are only dependent on wind energy, then we require 31 million wind turbines for fulfilling the total human consumption of 500 exajoules. So moving to the next slide, which is the relationship between speed and power or energy of the wind. So here are some energy calculations regarding the kinetic energy and the power of the wind. We are assuming v, small v, is the velocity of the wind. So the total kinetic energy of the wind is half mv square. As we don't know the mass of the wind or the air, we are taking it as density into volume. So the kinetic energy is half rho into capital V, which is the volume of the air that interacts with the blades of the turbine, into the square of the velocity of the wind. We can further simplify it by replacing the volume into the area, which is pi r square, and it is the area which is swept or covered by the blades of the turbine. And L is the length of the wind, or we can say the depth of the wind that interacts with the blades of the turbine at a particular point of time. So the kinetic energy is half rho into A, the area of cross section or the area covered by the blades of the turbine, into length into velocity of the wind, the square of the velocity of the wind. Now moving to the power. As we all know, power is the dE by dt, which is the rate of energy, the rate at which the energy can deliver. So by putting the values of kinetic energy here, we get half rho into area into the cube of the velocity of the wind. So by this, the kinetic energy of the wind is calculated, which is half rho into A into L into the square of the velocity, and the power we also get, which is equals to half rho into A into the cube of the velocity of the wind. So we can say the power of the wind energy varies with the velocity of the wind. We can also analyze the graph here between the power and the wind speed in km per hour. Here we can see as V increases the wind speed, the power also increases, and we know that the power varies with the cube of the velocity of the wind. As we have seen in the previous slide, that the wind speed is playing a crucial role. The power of the wind varies with the cube of the wind velocity. So regarding that, we are discussing some of the parameters associated with the wind velocity that is required for effectively operating the windmill. The first one is tip speed ratio. So it is the ratio of the rotational speed of blade to the wind speed, which means how much the wind speed affects the rotational speed of blade. That ratio defines that value. The second one is the cut-in speed, which is very important. It is the minimum wind speed at which the blade starts to turn. It will start to rotate, and this value is approximately lies between 10 km per hour to 16 km per hour. Third one is rated speed. the wind speed at which the windmill generates its rated power, which is approx 40 km per hour. This is the optimal value at which the windmill is capable to generate its rated power. And last and important point is cut out speed. After having a certain speed or a high speed of wind, limits its operation. For preventing the damage, the windmill has to be stopped at a particular wind speed, and that speed is approx 70 km per hour or above that particular speed. The windmill has to be stopped to prevent the damages.